Hello everyone. Today session we are going to continue with the Laplace transformation results. In the previous session we derived three results the Laplace transformation. One is for a constant function, the other one is an exponential function. In related to hyperbolic function we are deriving only sine function. Today, in the continuation of the same thing, we are going to derive four more results is there now. So first one is, now we are going to derive the hyperbolic function in terms of cosine. Then after that, trigonometric functions of sine, cosine and also a function 3 power n. So these are the four results we are going to derive today's class, and also we are going to solve some problems. Okay. So in continuation of the previous class, I am going to derive this one. Prove that Laplace of cos hyperbolic at it should be equal to s divided by s square minus a square. Okay, this is the proof they asked you for cos hyperbolic function. Okay, so just you have to remember one result is there now. For the hyperbolic function, you have to write down in terms of an exponential. It is quite very easy because we know that an exponential function result. Okay, so just you have to know the result of this. We know that cos hyperbolic at is simply it is an e power at plus e power minus at divided by 2. So this is the exponential form to convert the hyperbolic function. Okay. Then after that apply the Laplace transformation both sides. So if you are taking a cos hyperbolic at, it should be equal to 1 by 2 times. So I have to apply the Laplace transformation individual terms e power at plus Laplace of e power minus at. This is 1 by 2 is the term, a fraction term should have to multiply the two terms. Okay. We know that the Laplace transformation of e power at. In the previous class, we derived the result for e power exponential function. The result for Laplace transformation of e power at is 1 by s minus a. If positive is there, you have to put it minus. Plus, if negative is there, that's 1 by s plus a. So you can make a simplification work for this by taking an LCM, that is an s minus a, s plus a. This is an LCM. So here positive term is there, s plus a, then plus of s minus a. Now cancellation of these two. A further simplification is the Laplace transformation of cos h at. It should be equal to 1 by 2 times of s plus s, it is 2s, then all divided by s square minus a square. You should have to use the properties of basic properties of algebraic terms, that is an a minus b into a plus b formula. I have to use that. They become x square minus a square. Okay, and cancellation of these two. Then Laplace of cos hyperbolic at, it should be equal to s by s square minus a square. So this is the result for cos hyperbolic function. Okay. So just you can understand some example how to write the result for some different functions. An example, if I am taking a Laplace of cos hyperbolic 2t, just you have to compare here now in the result in terms of a, what is there now here? 2 is there now. The formula for this is only the replace in place of a, you have to replace 2. Okay. That is s divided by s square minus 2 square. Then s divided by s square minus 2 square. Or simply we can also write down s by s square minus 4. This is the result for that. Okay. And one more example, if Laplace transformation of cos hyperbolic 2 by 3 t is there now. What is there in place of a here? It is 2 by 3. Just you have to substitute the 2 by 3 in place of a. This is s divided by s square minus 2 by 3 whole square. Or if you want for further simplification work, you go for the simplification. Either you keep the answer in this form. If you want a simplification, this become s divided by s square minus 4 by 9. Because 2 square become 4, then 3 square become 9. Then taking a LCM and simplification work for this. Finally, we get 9s divided by 9s square minus 4. You can better to keep the answer in this form. That's enough. If you want a simplification, then you go for that. Okay. So this is the result for cos hyperbolic function. So then we move to the next result for trigonometric functions. We are going to find out the result for Laplace. We are going to prove the Laplace transformation results for trigonometric functions. Okay. Prove that Laplace transformation of sin at, it should be equal to a divided by s square plus a square. Okay. Now I'm going to prove this one. So, can proving of this one again by using the definition of Laplace transformation. Proof by definition of Laplace transformation. What is that? That is L f of t. It should be equal to 0 to infinity e power minus st then f of t into dt. So this is the definition of Laplace transformation. Then after that, in place of f of t, you have to substitute this trigonometric function sin at. Then Laplace of sin at, because the function they asked you find out the Laplace transformation for sin at. So that's why I am putting in place of f of t sin at. Okay. It should be equal to 0 to infinity e power minus st then sin at. Okay. So now I'm going to integration of this one. So we have to know one of the important results in the trigonometry for exponential along with the trigonometric function. You have to use that result to simplification of this integration. Okay, what is that? Then integration of e power ax sin bx. I have to use this formula. That is an e power ax into a times of sin bx minus b times of cos bx then all divided by a square plus b square. I have to use this result for simplification of this integration. Okay, so here what is there in place of a? What is there here now? In place of a, you have minus x. In place of b, we have here a. Now to substitute here now. Okay. Use this a equal to minus s, then b equal to a. So what we get the result? You have to check it now. Then integration of then Laplace of sin at, it should be equal to e power minus st. You have to remember e power minus st, a value is minus s, then sin at, then minus of b value a into cos at, then all divided by a square plus b square. Here the t ranges from 0 to infinity. So this is the value they given here, 0 to infinity. After make a simplification, then you have to apply your upper and lower limit. Okay. Just I have multiplied this exponential term for these two. This is completely constant, a square plus b square. You have to remember the a value is minus s. Then you have to write down here s square. This is s square. Then b value is there, a square. Then you have to write down this is a square. Then e power minus st minus s sin at minus a times of cos at, then divided by s square plus a square between the limits t 0 to infinity. Then apply the upper and lower limit for this particular function. Then Laplace of sin at, that should be equal to, then multiply this exponential term for these two functions. We have like that 1 by s square plus a square is constant, completely constant. I am taking outside. Then minus s e power minus at cos st, then cos, then sin at, then 1 by s square plus a square, minus s e power minus st sin at, then minus a times of e power minus st, then cos at. Your s ranges, t ranges from 0 to infinity. Now check it, what happens if I am giving a upper limit for that particular function. See here, in the place of t, you put in infinity, what we get now here, check it now. 1 by s square plus a square. In place of t, you put infinity, we get an e power minus infinity. E power minus infinity value is 0, then complete the entire term, they become 0. This become e power minus infinity. Then if I am giving a lower limit for this particular function in place of t, here s is there, e power 0 is 1, but sin 0 is 0. Then upper limit, then minus of lower limit for that particular function. In the second function, again the same status, a is there. Now in place of t, putting e power infinity, this become e power infinity, then cos 0 is 1, then minus of, if we are giving a lower limit, we have an upper limit, then minus of lower limit, a is there, e power 0 is there, then cos 0 is 1. Okay, we know that e power infinity value is 0, this is complete, that total term will be cancelled. Here also e power infinity is 0, this is the complete term will be vanish. But e power 0, I have to remember the value is 1, 1 into 1 we have 1. Then finally we have 1 by s square plus a square into, then minus into minus plus a. And finally we have sin at, it should be equal to a divided by s square plus a square. So this is the required result for Laplace transformation for a trigonometric function in terms of sine. Okay. So let me understand one or two example how to write down Laplace transformation for a particular function. Example, if I am taking a Laplace transformation of sine 4t, it is 4 divided by s square plus 16. One thing you have to remember, in hyperbolic function to trigonometric function, what is the only thing will be changed in the denominator symbol? You have to remember, in a hyperbolic function, this becomes s square minus a square. In general trigonometric function, it becomes positive value. Okay. Then Laplace of sine 1 by 2t. So this is 1 by 2, then all divided by s square plus 1 by 2 whole square. To remember, it's a function. In that function, you can write down. If t is present here, then it is a function. If t is not present, then it is a constant. You have to remember in your mind. Okay. So this is the result for trigonometric function in terms of sine. So then we move to the next result, trigonometric functions in terms of cosine. So now we are going to prove the one more is trigonometric function result, that is a cosine. Okay. Prove that Laplace transformation of cos AT, it should be equal to s divided by s square plus a square. Here also same thing, the difference for hyperbolic as well as trigonometric function. In the hyperbolic function percent, this becomes a square minus a square. Trigonometric function is there, now it becomes a square plus a square. So again prove by using the definition of Laplace transformation. Proof by definition of Laplace transformation. What is that? It's LF of t. It should be equal to, again, 0 to infinity e power minus st, then f of t into dt. So this is by the definition of Laplace transformation. Okay. In place of f of t, just you putting here cos at now. Then Laplace of cos at, it should be equal to 0 to infinity e power minus st cos at into dt. Okay. So again, it can be solved by using one more integration result is there now. That is an e power ax, then cos bx formula. You have to use the integral result. Then e power ax, a into cos bx plus b into sin bx, then all divided by a square plus b square. You have to use this result now. So here also same thing. The value of a, here taking a value of a is minus s, then value of b is a. So what we get now here, then Laplace of cos at, it should be equal to, just have to substitute here now, e power minus st into minus s cos at plus a into sin at, then all divided by, in place of a is minus s square, power is positive, because power having an even, the negative is also become as a positive, s square plus a square. Okay. Then between the limits, your t ranges from 0 to infinity. That means you have to apply the upper and lower limit. Then you go for further simplification work. Then Laplace of cos at, it should be equal to, make a simplification of work by taking 1 by s square plus a square, taking completely outside. Then after that, minus s, then e power minus st cos at plus a times of e power minus st sin at, then t ranges from 0 to infinity. Okay. Then after that, apply the upper end limit for two terms. Then check it what happens now. 1 by s square plus a square. Now giving a upper limit in place of here, in place of t, this become e power infinity. The e power infinity value is 0. You can write down directly 0. Then minus of, if you are giving a lower limit, in place of t, you have to remember. Minus of, in place of t, if you are given, this is minus s is there, e power 0, then cos 0. Upper limit, then minus of lower limit in place of t. Then here also, if you are giving here t value, e power minus infinity is 0. If you are giving t is 0 for t, this is e power 0, 1, but sin 0 is 0. Upper limit, then minus of lower limit. 1 by s square plus a square. Then minus into minus plus s, this value is 1, this totally is 0. Then finally, the Laplace transformation of cos AT, it should be equal to S divided by S square plus A square. So this is the required result for Laplace transformation in terms of cosine. So then you can understand one or two examples. Then Laplace transformation of cos 2t. Here, yes, don't write 2 here. That is only for trigonometry function in case of sine or maybe hyperbolic function. But in place of a, 2 is there. But in your formula for numerator, it should be in s. That is an s square plus 2 square, they become 4. Okay. Then Laplace transformation of cos 2 by 3 t, it should be equal to s by s square plus 4 by 9. Okay. So this is the result for writing the trigonometric function in terms of cosine. Okay. So now we are going to prove one more result is there. Now t power n. Now I am going to prove the last results of Laplace transformation, that is t power n, where n is a constant. So this is the last result. Prove that Laplace transformation of t power n, it should be equal to gamma n plus 1 s power n plus 1, or simply n factorial then n plus 1. The two cases will be appear here. One is for positive integer, the other one is a fraction. So this is the gamma function is there now. So before going to proving of that, you have to remember your second semester result beta gamma function concept. We are consider only here the result of gamma function. We know that I am writing here now the result of gamma function. The gamma n, it should be equal to integral from 0 to infinity e power minus x, then x power n minus 1. You have to remember this, the results of gamma function. And also have to know the gamma n plus 1, it is simply n into gamma n, or simply it is an n factorial. You already know these two results in your previous semester. Okay. So using that result, we are going to proving the one more important result of Laplace transformation, that is t power n. Okay. And also remember here, if n is there, this becomes n minus 1. Suppose I wanted to write in n plus 1 for this. If I am going to write on n plus 1, what we get now here? The definition of gamma n plus 1, it should be become 0 to infinity e power minus x, then x power n. Just you have to replace n to n plus 1. Both 1 will be cancelled. We are getting only into of this term. Okay. So this is the result I have to remember. Gamma n, this is the result I have to remember. Gamma n should be equal to 0 to infinity e power minus x, then x power n minus 1 into dx. Suppose in place of I wanted n plus 1 result, just you have to replace n to n plus 1, you get 0 to infinity e power minus x, then x power n into dx. Okay. So one more result is there now, it is gamma n plus 1, it is n into gamma n, or simply it is an n factorial where n is an integer. It is simply it is a positive integer we are considering here. Okay. Now I am going to prove this one by using the definition of Laplace transformation. Proof. By definition of gamma function. So now I'm going to prove by definition of gamma function. Okay. So not a gamma function, sorry, definition of Laplace transformation, sorry. So by definition of Laplace transformation, it is an L of f of t. It should be equal to 0 to infinity e power minus st, then f of t into dt. Now in place of f of t, you put Tn 0 to infinity e power minus st and t power n into dt. After writing the definition of Laplace transformation, I have to write down all these things. Okay. Then I want to solve by substitution method. Then put st equal to, you can take in as some z. No? It is a function. So I wanted to t is, we're getting like that, t is z by s. Then I wanted to dt, this become 1 by s into dz. And I'm going to take a substitution for this. St as in z. A product of two function is there, I make it as a single function. Then I wanted to t because I need here t now. So that's why I wanted to t is z by s. If we differentiate this one with respect to t, we get like that, dt equal to 1 by s dz by ds. If we make a cross multiplication of a particular term, we get like this. Okay. Then also change their limits. Now check the limits, what they are changing. So given limits are all are in terms of t. So I wanted to convert these limits in terms of z. What happens if I am giving a t equal to 0? If t equal to 0, z is also 0. If t equal to infinity, z is also an infinity. Just here now, putting 0 here, the entire term becomes 0. If z, the limit is also becomes 0. If you are giving an infinity, then z is also become an infinity. Okay. So then you check it what happens now. Then Laplace transformation of t power n, it should be equal to, I am taking this and no changes in the limits, 0 to infinity e power minus z in place of t, that is z by s whole power n in place of dt. In place of t, you put z by s. In place of dt, 1 by s into dz. 1 by s into dz. Okay. Make a simplification work. 0 to infinity e power minus z, z power n, s power n, 1 by s into dz. If two bases are same for s, then add their respective powers. It will give 1 divided by n plus 1, then 0 to infinity e power minus z, then z power n into dz. Just follow this result, exactly similar of your definition of a gamma function. Just you have to watch it now. It's a definition of gamma function. So now we can write down this as in gamma n plus 1 divided by s power 1. This is the first case what they ask in the result, gamma n plus 1. Suppose what happens if they ask the extension of this. We know the result of gamma n plus 1, that is n into gamma n, or simply we can write down as an n factorial. So these are the results we already studied in the previous semester. Using that that result, we can write down directly, this is also an n factorial divided by s power n plus 1, where n is a positive integer for this one. Okay. So let me understand some examples regarding about how to write down the Laplace transformation for t power n. You have to remember n is a constant term now. Okay. So I am writing some examples. Then Laplace transformation of t power 3 is there now. Just you have to observe here. It's a whole number 3. It is not a fraction. You can write down directly for this one. This become 3 factorial, then whole to the power of 3 plus 1. That is 3 factorial, we know that it is 6 by s power 4. Or either keep the answer in 3 factorial by s power 4, like that. Suppose if I am writing a Laplace transformation of t power 100 is there now, where n is a constant now. You can simply write down as an 100 factorial, then divided by, so had what there you obtained here, it is 101 now. This is for whole number they appear. You can write down directly in terms of n factorial. What happens if the fractions appear? Then you can take the Laplace transformation of t to the power of 1 by 2 is there now. It's not possible for writing in n factorial form. So in that case, you can apply this result as a gamma n plus 1 divided by s power n plus 1. That result have to apply for this one. So this become gamma 1 by 2 plus 1 divided by 1 by 2 plus 1. If you want further simplification, use this result concept of this one. Gamma n plus 1 is there now. It is n into gamma n concept you have to use and write down the result for the fraction terms. Okay. So this is become like that 1 by 2. It is gamma 1 by 2 into gamma 1 by 2, then s to the power of 3 by 2. We know the result of gamma half. It is a root pi. Remember, the gamma half value is root pi. You can write down for the root pi for this. It is a 2 times of s to the power of 3 by 2. So this is the way we can understand the result for Laplace transformation. Okay. So now we are going to solve some problems. So before going to solve the problems, just you have to recall all the results of Laplace transformation one by one. Okay. So just I am writing here all the things now here. So first result number 1, we are proving a Laplace transformation of any constant function, that is an a divided by s. Here your s should be greater than 0. This is the first result we are proving. In the second result, it is an exponential term. It is an e power at, or maybe positive or negative, whatever it may be. This become 1 divided by s minus a. If it negative comes, they become plus. Here also have to remember s should be greater than a. Should not be equal to 0. Then third result, in Laplace of suppose e power minus at, the sub result of this become s plus a. Here also s plus a, it should be greater than 0. Okay. Then fourth result, we are derived in terms of hyperbolic function, that is sine hyperbolic at, it should be equal to a divided by s square minus a square. Then fifth result, it's a Laplace transformation of cos hyperbolic at, it should be equal to s divided by s square minus a square. Then sixth result, it is a Laplace transformation of sin at, it should become an a divided by s square plus a square. I have to remember the difference of this here now. Okay, understand? Then the seventh result is a Laplace transformation of cos at, it should be becomes s divided by s square plus a square. The last result is a Laplace transformation of t power n. It is two cases will be appear. One is for the fraction, the other one is a positive integer. So it is a gamma n plus 1 divided by n plus 1, or simply it is an n factorial divided by n plus 1. You have to remember in this case, if n is a constant, it should be a positive integer like that, 1, 2, 3 like that. In that case, you can use this result now. Suppose if fraction is up here, you can use this result, gamma in terms of gamma. I have to keep the result in terms of gamma and write down the results. Okay. Now, sorry. Now you can understand all these results. You can solve some problems. Okay, you can solve some, one or two simple problems. You can understand that. So firstly, I am going to take an example. Find the Laplace transformation of the following. Find the Laplace transformation . Find the Laplace transformation for the following. So first I am taking the first example. What is the Laplace transformation of 6 they give? So see the results. The 6 will be coincide for which result I have to remember now. See, a 6 is a constant. It definitely coincides with the first term. So then you can write down the result for this 6 by S. Okay. Then a second result now. I am taking here sine 2. I am taking a sine 2. You have to remember here now, sine 2 is a constant. It is not a function. If t is present, then it is a sine. If sine 2t is there now, it is a function. Now it is a constant. What's the result for that? Sine 2 is, it is sine 2 divided by, yes, you have to write down like that. Okay. In the third result, so I am going to write down like that. Then e power of 4t. It's going to the exponential term, so you can write down that is 1 by s minus 4. Then fourth one. Then Laplace of e power minus 6t is there now. So it becomes, here minus is there, you have to remember, minus of minus 6, then 1 divided by, it is an s plus 6, you have to remember. Okay. Then fifth result, it is a Laplace transformation of 2 times of sine hyperbolic 4t is there now. Sine hyperbolic function have to remember here, a by s square minus a square. But if 2 is there now, it is a constant function. I already told in the basic beginning. If constant into function is there now, you keep the constant as it is, only in the case of product form. You keep the constant as it is, then only I have to write down the result for function. Okay, that is I have to take in 2. Then Laplace of sine hyperbolic function is 4 divided by s square minus 4 square, it become a 60. That is 8 by s square minus 60. Then sixth one, the Laplace transformation of 2 times of cos hyperbolic 5t. So again you to keep as it is. Then the result for this s divided by s square minus 25. That is 5 square, it become a 25. So now it becomes 2s divided by s square minus 25. Okay. Then similarly, you move to the next one. In the Laplace transformation of in terms of sine 10t is there now. Sine 10t. What is that? Constant 10 divided by s square minus 100. Don't write minus here. You have to remember, yes, it is the trigonometry function. You put here plus. That is 10 divided by s square plus 100. 10 square become 100. Then Laplace of cos 9t is there. It is an s divided by s square plus 9 square. That is an 81. So this is the way we can understand the concept of writing the Laplace transformation. Then Laplace transformation of t power 4 is there. It is simply 4 factorial, then s power 4 plus 1. It is 24 divided by s power 5. Okay. So suppose the fraction is there now, t to the power of 2 by 3 is there now. It is simply I have to write down in the form of gamma 2 by 3 plus 1, then s to the power of 2 by 3 plus 1. If you want a simplification, that is gamma 5 by 3, then all divided by s to the power of 5 by 3. So this is the way we can write the result for Laplace transformation for different functions. Okay. Okay, just I recall it. What are the things we have done in this session? So we are going to proving a 4 results, that is for one for hyperbolic function of cosine, then 2 trigonometric functions, and also for one the t power n, where n is a constant. These are the 4 results we are done in this session. And also we can understand how to write the Laplace transformation for these particular functions, okay, for all these days.